Hello everyone, if you are available for the session, please say hi in the chat window. Hello everyone. Hi Jay. So let us wait for 2 minutes for everyone to arrive. Jay, can you message in the Telegram group that we are live? क्या आप Telegram group message कर सकते हैं that we are live and we can start? Hi Mary. Hi Kajal. Hello everyone. Good. So in today's session, जो previous class हमारी हुई थी, the previous class we have discussed some basics of finite automatas, and we have seen what exactly is a finite automata, and we have seen some examples of finite automatas. So today's class we are going to divide this session into 2 or 3 sessions, and every session will be of 1 hour, 2.5 hours each. So जैसे for example this is your first session. In this first session I'll take more examples related to the finite automatas. Then in the second session we will be discussing about what is NFAs, that is non-deterministic finite automatas. So after non-deterministic finite automatas we will be discussing about how to convert an NFA to a DFA. आप किसी non-deterministic finite automata को NFA से DFA में किस तरीके से convert कर सकते हैं. After this we will be discussing about the minimization of finite automatas, and then we will be looking at some of the operations on finite automatas. तो हमारे पास 4 से 5 आज के agendas है. So this is the first session here. In the first session I'm just going to discuss some of these examples. I'm not going to discuss all of them. Obviously I have to give you some homework to practice. So I'll give you the solutions of those problems though that I'm going to give you as a homework, but again some of these problems I'm going to discuss, some of these difficult problems, little bit difficult you can say, or you can say little bit tricky, I'll give you as a homework. Okay, so that you can practice. Fine. तो हमारे पास this is the first session, and in this first session we will be taking the DFA examples. Then maybe in the next session we will be discussing about NFAs and what are NFAs and how to convert an NFA to a DFA. That will be a second session, and in the third session we will be discussing about how can you minimize a finite automata and some of the operations related to the finite automatas. Okay, is it clear with all of you? So we can start maybe. जल्दी से लिख दीजिए चैट विंडो के अंदर if you guys are ready with your pen, paper and notebooks and everything. तो हम लोग start कर सकते हैं. Just write the chat window so that we can start as soon as possible. Good. Great. So some of these problems we have done yesterday also, and some of these problems are very easy. जैसे कि for example the problem number 1 is very easy. So problem number 1 says we should have exactly 1A. So any language. So here we are taking summation is equal to A comma B, and the problem is that in any string we should have exactly 1A. We cannot have more than 1 A's. Okay. Now in this case what are the strings that are possible? क्या क्या strings possible है आपके पास? You can have a single A, you can have AB, you can have AB B, you can have B A B, and so on. So there are no restrictions on the number of B's. The only restriction is on the number of A's. So how can you do it? It's very easy. So this is your initial state, which is Q0. In the beginning you can have any number of B's, doesn't matter. आपके पास कितने भी B हो सकते हैं. We are not really caring about the number of B's. We are only caring about the number of A's. So as soon as we get exactly 1A, we go to the state Q1 and we are going to accept it. Okay, and here we can have any number of बीज अगेन, तो यहाँ पर भी आपके पास कितने भी बी हो सकते हैं. बट अगेन हियर वी कैन गेट मोर एज ऑल्सो. तो जैसे ही आपके पास एक और ए आता है, इफ यू गेट वन मोर ए, यू गो टू द स्टेट Q2 and you are going to keep it as a reject state. That means if you have one a, then you are going to accept the string. But if you have more than one a, then you are going to reject. So problem is very easy. Problem says we should have exactly one a. So second problem says no more than 3 a's. So that means you can have 1 a, you can have 0 a's, you can have 2 a's, you can have 3 a's, but you cannot have more than 3 a's. Okay, so here the strings that are possible are epsilon can be there, single b can be there, double b can be there. You can have any number of b's, because we are not putting any restriction on the number of b's, we are only putting restrictions on the number of a's. So we can have single a, we can have double a, we can have triple a, but we cannot have more than 3 a's. But again here in these strings we can have any number of b's. So for example we can have b a b, we can have b a b, and so on, right? So in this problem we can see we are not putting any restrictions on number of b's, we are just putting restrictions on the number of a's. यहाँ पर हम सिर्फ number of a's के ऊपर restrictions डाल रहे हैं, we are not putting any restrictions on number of b's. So that means this is your initial state which is Q0. And if we do not have any a, अगर आपके पास कोई भी a नहीं है, that means if the string is epsilon, or even if the string is only containing b, then still we are going to accept it. तो अगर आपके पास कोई भी a नहीं है, that means the string is epsilon, we are going to accept it. Or if the string is only containing b, still we are going to accept it, because we are not putting any restrictions on number of b's, we are just putting the restrictions on number of a's. And then if you get 1a, again you are going to accept it, because we should have a's less than or equal to 3. So if you have 1a, still you are going to accept it. If you have 2 a's, still you are going to accept it. And if you have 3 a's, still you are going to accept it. But if you have more than 3 a's, then you are going to reject everything. So more than 3 a's are not acceptable. So here after this you can have any number of a's and b's, you cannot accept it. But if you have 1a, 2a, or 3a, you are going to accept everything, because we are not putting any restrictions on number of b's. So this is the solution of the second problem, and this is the solution of the first problem. Is it clear? Correct? इसमें कोई doubt तो नहीं होगा. These problems are very easy. So third one says at least 1a and exactly 2 b's. आपके पास कम से कम एक a होना चाहिए और दो मतलब एटलीस्ट 1a, कम से कम एक a हो, और b's के ऊपर वी आर नॉट पुटिंग एनी रिस्ट्रिक्शंस. अगर आप यहाँ पर चेक करेंगे, सो दिस इज अ लिटिल बिट ट्रिकी एज कंपेयर टू द फर्स्ट टू. पहले जो दो प्रॉब्लम्स थी दे वर वेरी इजी, एंड दिस थर्ड प्रॉब्लम इज अ लिटिल बिट ट्रिकी एज कंपेयर टू द फर्स्ट टू प्रॉब्लम्स. ओके, सो इन दिस थर्ड प्रॉब्लम व्हाट वी आर ट्राइंग टू डू इज कि आपके पास if you have 0 a's, still it is acceptable, right? जैसे at least 1a. Okay, so that means if you have 0 a's, so if you have just the string which is bb, then still it is acceptable. If you have 1a, so we can have the string as abb, you can have the string as bab, you can have the string as bba. So if you have exactly 1a, then you can put anywhere. ये जो b है, these b can come anywhere. b जो है कहीं पर भी आ सकता है. These b can come in the beginning, they can come in the middle, they can come in the last, anywhere. But we should have exactly 2 b's, and secondly we can have at least 1a. So that means we can also have strings where there are 2 a's. So we can have double a, double b, we can have a b, ab, we can have ba, ba, we can have a double ba, and so on. So basically in this case what we are trying to do is that we should have exactly 2 b's, we cannot have more than 2 b's, but number of a's should be at least 1. तो यहाँ पर आपके पास है at least 1a हो सकता है. So this जो first thing है, this cannot be there, because at least 1a is necessary. So we cannot have double b, तो double b नहीं हो सकता. We should have at least 1a. We can have 1a, 2a, 3a, 4a, 5a. So this string which is double b, it cannot be accepted. ये जो string है ये accept नहीं हो सकती. Okay, so what we have to make sure is this A can come anywhere and these B are exactly 2. So जो A है वो कहीं पर भी हो सकता है, एक मिडल में भी हो सकता है, बीच में भी हो सकता है और एंड में भी हो सकता है. Anywhere you can have B's. Okay. तो इस प्रॉब्लम को कैसे टैकल करेंगे? How can you tackle the problem? So this is your initial state. Let us suppose this is Q0. Okay. Now in this problem, first of all, I'm only interested in making a DFA. इस प्रॉब्लम के लिए I'm not really interested in how can we make a minimized DFA, because if you have sometimes you get tricky problems, then in case of tricky problems you should first of all you should be able to make a DFA. If the DFA is minimized or not doesn't matter. So first of all you should be able to make a DFA, and secondly we can easily minimize that DFA. उसके बाद हम लोग उसको easily minimize कर सकते हैं, but at least you should be able to create a DFA. Okay. तो यहाँ पर what we are trying to do is we will try and create a DFA. That's it. Okay. Minimization will be a second part. इतना clear हुआ सबको? अब here what can happen is you have A जो है वो beginning में भी हो सकता है. Your first character can be A, correct? और your first character can be B. अगर आपका first character B है, still you have a choice. So we are making choices here. So you are checking if the first character is A, that means you have at least one A, and then you should have exactly two B's. And here we are trying to do, we should have, if the first character is B, then A can be in the middle. तो A जो है उस केस में हमारे पास middle point पर आ सकता है. Okay. So what you can do here is you can go to the state Q1 because you got at least one A. Now you can have any number of A's. So because we are having at least one A and exactly one B is now here, and if we get again we can have exactly one more B, and then we are going to accept it, right? So what we are trying to do is if you get at least one A in the beginning, then after this you can have B's which is exactly 2, right? And you can have any number of A's. जो A's हैं वो कितने भी हो सकते हैं, लेकिन B जो है वो exactly 2 होने चाहिए. तो पहले हमने बस ये make sure किया कि हमारे पास exactly एक A तो आ ही जाए, उसके बाद extra A भी हो सकते हैं. तो ऐसा भी हो सकता है we have the string like 3 A's B A B, right? So यहाँ पर exactly 2 B हैं and at least 1 A है. So this string is also accepted, right? And if you get more than 2 B's, then you should go to a trap state and you should not accept anything after this. Okay, so this is the case when A is in the beginning. But if the first symbol is B, in that case again 2 cases can be there. The next symbol can also be B, or the next symbol can be A. If the next symbol is A, okay, so if the next symbol is A, you can go to the state Q6 because at least one is there and we got 1B. Okay. And if the next symbol is again a B, then we have to make sure that one more A should be there. Okay, so if the next symbol is B, then I can go to the state Q7. So here I created a transition for A and B. Now here I have to create a transition for both A as well as for B. Here you can have any number of A's, but if you get a B again, तो आपके पास you can go to this state. I feel that should be correct, right? So because if you get exactly one B, then you can have A in the middle, you can have any number of A's, but then again you can have a B here, उसके बाद you can have again any number of A's. So if you get exactly 2 B's, then only you will go to the final state here. Now in this case what we are trying to do is we will go to the state Q7 only if we get exactly 2B. उसके बाद we need at least 1A. So here if we get at least 1A, then I can go to this state. Okay. But if I get one more B, then I should not accept it. If I get one more B, then I should not accept it. Okay. Now think about it. What we are trying to achieve here. Is it correct? Just have a look at it and tell me, is it correct? Just try and analyze this one. देखो this kind of problem I'm not really trying to minimize. I'm not really trying to create a minimal DFA here in this problem, because this can be a little bit tricky to understand if you want to create a minimal DFA in the one go. So that might be a little bit tricky to understand. So what I'm trying to do is I'm just trying to create a correct DFA, not a minimal DFA. Okay. तो अगर आप यहाँ पर फिर से प्रॉब्लम को समझेंगे, let me just summarize the problem again and then you can answer me whether it is correct or not. Okay. So the problem says we should have at least one A and exactly 2 B's. आपके पास कम से कम एक A होना चाहिए और सिर्फ exactly 2 B होने चाहिए. अब वो जो a है वो कहीं पर भी हो सकता है, that a can be in the beginning. You can have the strings which is a b b, right? So a number of a's can be there in the beginning, or you can have the a's in the middle also, जैसे b a b, or you can have b double a b, or you can have b triple a b, and so on. So you can have a's in the middle also. You can have a's in the end also, as well as it can happen that a is in the beginning, in the middle, and in the end. So you can have a anywhere. So we are trying to analyze three cases here. The first case is if the string starts with a, that means you got exactly at least one a. Now you can just worry about the number of b's. तो ये जो है आपके पास जो फर्स्ट ट्रांजिशन है यहाँ पर, द फर्स्ट रो है, दिस इज जस्ट टेकिंग केयर कि हमारे पास कम से कम एक ए आ जाए. उसके बाद आपके पास कितने भी ए हो सकते हैं, लेकिन बी हमारे पास एग्जैक्टली 2 होने चाहिए. इन द सेकंड केस अगर स्ट्रिंग जो है हमारी बी से स्टार्ट होती है, सो अगेन यहाँ पर हमारे पास 2 केस बनेंगे. अगर बी से स्टार्ट होती है तो नेक्स्ट सिंबल कैन बी बी और नेक्स्ट सिंबल कैन बी ए. अगर स्ट्रिंग बी से स्टार्ट हुई और अगला सिंबल भी बी है तो हमारे पास 2 बी आ चुके हैं, वी गॉट 2 बीस. नाउ वी हैव टू मेक श्योर कि हमारे पास कम से कम एक ए आ जाए, देन वी आर गोइंग टू एक्सेप्ट इट. बट इफ वी गेट वन मोर बी, then we are going to reject it. But if the first symbol is b and the second symbol is a, then third symbol can be anything. It can be a or b, but we have to make sure कि हमारे पास exactly एक ही b आना चाहिए. We cannot have more than one b, but we can have any number of a's. Is it clear? Any doubts in this? इसमें कोई डाउट है? It was little bit tricky, right? Good. Good. If it is clear, please try and solve this one, because this is exactly 2 A's and more than 2 B's. So this is something that you can work as a homework. I can give you a solution for this, but because we have done this one, so I'm not going to solve this one. तो ये हमने कर लिया है, so मैं इसको अब solve नहीं करूँगा. Okay? So you can do it by yourself. Now check out this one, which is every A is followed by BB. यानी कि कहीं पर भी अगर आपके पास A आता है तो उसके बाद हमेशा BB होना चाहिए. So that means if we have a string which is B, no problem, because there is no A's, because they are only putting the restrictions on A. What they are saying is if we get a A, it should have BB, right? We can also have a string like A triple B. Why? Because this A is followed by BB. उसके बाद उसने B के लिए और कुछ भी नहीं बोला. What they are trying to say is कि every A should be followed by BB. After that we can have any number of B's. So we can also have a string like B B B A B B and so on. So whenever you get a A, you should get exactly BB. You can also have a string which is A B B A B B B A B B, right? So here you can see every A is followed by double B. Okay, so these strings can be there in this language. So you have to make a DFA for this. आपको इसके लिए एक DFA बनाना है. Hi Rahul, okay, Nitu and all. तो यहाँ पर हम लोग कैसे करेंगे? So this is your state which is Q0. So in the beginning you can get any number of B's because they are not putting any restrictions on number of B's. So let us assume this is your B. But if you get a A, then you should have exactly BB, right? Then we can go to the state Q1, then you should have 1B. We can go to the state Q2, then you should have one more B, and then I'm going to accept it, right? So whenever you get a A, you should get BB, okay? Now if this A is followed by 1A, then I can go to the state which is Q4 and it is a trap state. I hope it is visible. क्या आप सभी को विजिबल है? Yes, I think it is visible, right? So if I get A and A, that means if I get a string which is AA BB, now this string should not be accepted because the first A is not followed by BB. तो यहाँ पर अगर एक A के बाद दूसरा A आपके पास आ जाएगा, then you are not going to accept it, you are going to reject it. Now if we have a string like A B A B B, now again this should not be accepted because this A is not followed by BB, right? तो यहाँ पर अगर A B उसके बाद अगर दोबारा से आपके पास A आता है, still you are not going to accept it. Okay, so this A is followed by exactly 2 B's. After this you can have any number of B's. You can have any number of B's, लेकिन उसके बाद अगर आपके पास exactly एक और बार फिर से A आता है, so if you get one more A, then you can go back to this state. So यहाँ पर क्या होगा? Every A is followed by BB. Is it clear? कोई डाउट है इसके अंदर? So we have done this one also. every A is followed by BB. Any doubts? Do you have any doubts till now? Good. So I have a lot of examples. Everyone can understand easily. A lot of examples are there. So let me rub this one. Just do one thing. Write this down in your notebooks. अगर आपने नहीं लिखा है, just write this down in notebooks. Jay, Mary, Pratibha, and write done in the chat window. As soon as you have done it, तो उसके बाद chat window पर done लिख दीजिए. Good. So we have seen these problems till now. So I'm going to rub these problems. Now this problem is every BB is followed by a single A. Now this problem I'm not doing, I'm giving you this problem as a homework because the similar problem we have already done. So previous problem was every A should be followed by double B. Now this problem is every double B is followed by single A. So this problem I am giving as a homework. If you have a doubt, please ask me and I can give you the solutions of this problem also. Let me take the next problem. They are saying all the strings containing double A but not triple A. That means if you look at this problem here, this is very interesting. Why? Because we can have a string which is single B. Okay, I mean we can have a string which is double A. We can have BAA, we can have double A, B double A, we can have B double A, BB. I mean we are not putting any restrictions on number of B's. We are just putting that we can have double A's but we cannot have triple A. This thing cannot be there. We cannot even have 4 times A, right? This thing cannot be there. So what we are trying to do is we are just saying that we should have double A's but we cannot have triple A's. So this is the restriction that we are putting. We are not putting any restrictions on number of B's. So all the strings containing double A but not triple A's. So if you look at this example here, तो यहाँ पर क्या होगा आपके पास? This is your initial state. Let us assume it is Q0, and we can have any number of B's in the beginning. आपके पास beginning में कितने भी B हो सकते हैं. As soon as you get 1A, go to the state Q1 because आपके पास single A अब आपके पास आ चुका है. Then you can have, if you have a B again, so every all strings containing double A but not triple A's. अब यहाँ पर इसको देखो, एक चीज और ध्यान से देखो, यहाँ पर strings containing double A, they are just saying they should contain double A. It does not mean they cannot contain single A. That means if we have a string which is B single A, B double A, so this string is also accepted. Right, so they are saying strings containing double A but not triple A's. तो यहाँ पर in this case we can also have this string because it is containing double A but we can also have a single A. Okay, now that means if you get a B here, then you go to the states, and if you get one more A here, that means we are having exactly a double A, then we can go to the state Q2 and we can make it as a final state. Here again we can have any number of B's, but again we have to make sure that we should not have 3 A's. So what I'm trying to say is if after Q2 if you get one more A, then go to a state Q3 and that should be a trap state. Okay, यानी कि you'll only reach to the state Q3 if you have triple A's. आप Q3 स्टेट पर सिर्फ तभी पहुंचेंगे जब आपके पास ट्रिपल A's हैं, but if you have double A's exactly, then you'll only reach to the state Q2. And in Q2 if you get a B, then you go to this state. So just make sure whenever I'm creating a diagram like this, जब भी मैं इस तरह के डायग्राम बनाने की कोशिश कर रहा हूँ, so यहाँ पर आपके पास क्या हो रहा है कि in these cases I'm trying to make sure that every state should contain exactly 2 symbols A and B. हर एक स्टेट के पास 2 आउटगोइंग ट्रांजिशन होने चाहिए, एक ट्रांजिशन होना चाहिए A के लिए और एक ट्रांजिशन होना चाहिए B के लिए. Now Mary just look at it here, they are saying all strings containing AA but not AAA. So what they are trying to say is कि आपकी जो string है, whatever your string is, it should have this AA, right? Does not mean it cannot have single A. It can have single A, but it should definitely have a AA. So if the string is containing this AA, then the string is accepted. Is it clear? Fine. Now look at the next example here. So these problems we have done till now. Next example is a raised to power n, b raised to power n such that n comma m is greater than or equal to 1. Now this problem is interesting. Why this problem is interesting is because what we are trying to say is that in the beginning of the string we should have only a's and then we should have only b's, and a can be greater than 1 and b can also be greater than 1. What do I mean to say by this is, that means we can have a string which is ab, we can have a string which is double AB, we can have a string which is triple AB, we can have a string A double B, we can have a string A triple B, we can have a string A B B B, right? B, we can have a B B B and so on, but we cannot have A B A. ये string यहाँ पर possible नहीं है. We cannot have A B B A. We cannot have A B A B. Right, so what they are trying to say is that in the beginning we should have only A's and then we should have only B's. We should not have a mixture of them. Beginning में जैसे string है, beginning में string के हमेशा सिर्फ A होने चाहिए और उसके बाद सिर्फ और सिर्फ B होना चाहिए. We cannot have anything. If B starts then we cannot have A. अगर कहीं पर भी string में B आ जाता है तो उसके बाद A नहीं आ सकता. And we cannot have a string which is containing only B's. This cannot be done. So if you look at this problem, how can you make a DFA for this? This is your initial state which is Q0, okay? Because they are saying that m comma n is greater than or equal to 1. So these are two different problems. In the second problem where we have m comma n is greater than or equal to 0, the solution will be different, okay? And in this case the solution will be different. These are two different problems, so there will be two different solutions. So in this case if you look at it here, so if we have a raised to power n, b raised to power n, that means we should have at least one a, then we will go to the state q1. Then after this we can have any number of a's, and then we can have at least one b, then go to the state q2, then we can have any number of b's, okay? But in the beginning here this is an accepting state, but in the beginning if you get a b, then go to the trap state which is q3, and here we can have a or b. And here at the Q2, if you get 1A, then again you will go to the trap state. So again you will look at it here, we have created one transition in every state for every symbol. जैसे Q1 के अंदर A के लिए ट्रांजिशन है, B के लिए ट्रांजिशन है. Q3 के अंदर A और B के लिए दोनों के लिए एक ट्रांजिशन है. Q1 के अंदर we have a transition for A and we have a transition for B. So for every state you have to create one transition. But if you look at the second part of this problem, now this second part is little bit different. Why? Because here what they are trying to say is, they are saying that we have an, bm such that n comma m is greater than or equal to 0. That means the value of n can be 0 as well as the value of m can be 0. देखो जब मैं यहाँ पर बोलता हूँ an, मतलब अगर मैं बोलता हूँ a square, if I say a square it means double a. If I say a square b cube, a cube, it means it is a double a, triple b and triple a's. So whenever we say powers here, so power means the number of, wow, they are repeating itself, okay? Fine. Now if you look at this problem here, it is little bit different. Why? Because they are saying that we can have 0 a's also. तो यहाँ पर अगर आप check करेंगे, in this case you can have a string which is single b, you can have a string which is single a, you can have string which is double a, you can have a string which is triple a, you can have string double b, you can have strings triple b, you can have double a double b, you can have single a double b, you can have single a triple b's and so on, right? So what they are trying to say is, after a, if b start then only b should be there, a cannot come, correct? So if you try to make a DFA for this, it will be slightly different as compared to this, because देखो एक बार, you have a state, initial state as Q0. So in the beginning if you get a, right, then you will go to the state Q1, then you can only have a, but if you get a b, then you should only get a B. But again, this should be a final state because हमें single A, double A, all these A's should be accepted. Even here epsilon should also be accepted because in this language epsilon is also present. तो यहाँ पर जो initial state होगी, this state should also be a final state. यहाँ पर initial state cannot be a final state because here the minimum length of the string should be 2. अगर आप यहाँ पर check करेंगे in this problem, the minimum length of the string should be AB. So minimum length is 2, but here the minimum length of the string can be 0 क्योंकि यहाँ पर a की पावर भी 0 है और b की पावर भी 0 हो सकती है. If both of them are 0, in that case we are going to have epsilon, therefore you can have minimum length of the string as 0. So for this case your initial state q0 can be final state. तो यहाँ पर आपकी जो initial state है वो एक final state हो सकती है. Then we have a state q1. Now this q1 state, if we get 1a, again q1 state is an accepting state. अब यहाँ पर q2 state है, q2 is also an accepting state. We can have any number of b's here. But अगर q2 के बाद एक और a आ जाता है, then I'm going to reject it. I'll go to the state q4, and this is going to be a trap state. Okay. I hope this much is clear. And here at q0, if we get a b directly, then we'll go to the state q2. So now you can clearly see that what are the strings that will be accepted here. तो आपके पास epsilon acceptable है. You can have any number of a's in the beginning. You can have 1a, 2a, 3a, 4a, any number of a's in the beginning. All of them are acceptable. So once b start, then only b can be there, then a cannot come. Okay, so this is the diagram for this. So there's a difference in the diagram for both of these two problems. Even अगर आप check करेंगे in both of these problems, there's a difference of 1 and 0. यहाँ पर बस आपके पास 1 है और यहाँ पर आपके पास 0 है, but the diagrams are quite different. Is it clear? Any doubts? इसमें कोई doubt है मेरे प्यारे friends? Pratibha, do you have any doubts? Rahul, Mary, Jay? Have a look at this problem and tell me if you have any doubts. अगर आपको कोई भी डाउट है तो आप उनसे पूछ सकते हैं. If you don't have doubt और अगर आपने इसको नोटबुक में नोट कर लिया है, just write down in the chat window so that we can move forward. Let me know if you have doubts. Hi Srinivas. Pratibha, Jay, Mary, are you there? Pratibha, Mary, Jay, Rahul, Srinivas, Neetu, Afshan, Aparna, Vinod, Reena. Those who are online, just say hi again so that we can continue the session. आप में से जो online है, please say hi. Okay, let me continue with the problems. So, I believe आपको इतना समझ में आ गया है. So, let me continue with the problems. So we have done these many problems so far. Now these are the remaining problems. So the next problem is saying a raised to power n, b raised to power m, c raised to power k, and where n, m, k is greater than equal to 1. Now this problem I'm going to solve, but you can change this problem for greater than equal to 0 also. और जो 0 वाली problem है, I want all of you to solve that problem if we have n, m, k is greater than or equal to 0. Okay. So here what they are trying to say is that we can have a string which is a, b, c. We can have a string which is double a, single b, c. We can have a string which is a, double b, c. We can have a string a, b, triple c, and so on. Right? So what they are trying to say is you should have at least one a, you should have at least one b, you should have at least one c, and they should be in order. Right? So here you can see it's the initial state which is q0. In the beginning you should have at least one a. See, in this case summation is equal to a, b, c, because here three symbols are mentioned. यहाँ पर तीन symbol mentioned है, तो इसी वजह से summation में आपके पास a, b and c, these three things will be there. Now we'll go to the state q1. If we get n number of, if we get a b, we'll go to the state q2. We can get n number of b's. If we get a c, we'll go to the state q3. Again we can get n number of c's, and here this should be an accepting state. And after this, if you can get a or if you can get a b, you'll go to the state q4, and this is going to be a rejecting state for all of them. And then we are going to create a trap state also. For example, here in the beginning if you get a c, I'm not going to accept anything. Here after this, if you get a c, I'm not going to accept anything. And here after this, if you get a, I'm not going to accept anything. And then this is going to be a trap state which is, let us suppose, q5, and you can get any a, b and c for this. So here you can see that for every state we have to create three transitions. हर एक state में आपके पास तीन transitions होंगे. In the first state q0, you are going to create a transition for a, b and c. Here also you are going to create a transition for a, b and c. Here also you are going to create a transition for a, b and c. Here also a, b and c, and here also a, b and c. For each of these symbols which is a, b and c, you are going to create transitions here. Okay, तो ये जो आपके पास है, this is also done. So I hope that you understood this part. Now the next part is this one, so which is a raised to power 3m, b raised to power 3n. तो अगर आप यहाँ पर चेक करेंगे, if you look at this problem here, तो इस प्रॉब्लम में what they are trying to say is number of a's should be multiple of 3's and the number of b's should be multiple of 3. तो in this case, if you get a, so you should only get a in the beginning, right? So here again you can see that m, n is greater than equal to 0. ठीक है, so that means we can have 0 a's also. So 0 a's is also accepted. We can have 0 a's which is q0 state. Okay. Now if you get a in the beginning, then you should have multiples of 3. You go to the state q1, again you have a, you go to the state q2, again you can get a. So this is how we get a's which are multiple of 3's. Okay, and in between a's, these a's, b should not be there. And if there's a b, again b should be a multiple of 3. तो यहाँ पर as I said, a raised to power 3m and b raised to power 3n. तो जो b है आपके दे शुड आल्सो बी मल्टीपल ऑफ 3. सो यू गो टू द स्टेट विच इज Q3. तो आप Q3 स्टेट पर जाएंगे एंड आफ्टर गोइंग टू द स्टेट Q3 you can have one more b, and after this you are going to the state Q4. Again you can have one more b, you're going to the state Q5, and Q5 will be an accepting state, and again b is there because we want the b's to be multiple of 3. So this state here, it should be a final state, as well as this state Q5 is a final state. So this is the basic skeleton of the diagram. This problem, for this problem, this is going to the basic skeleton, because आपके पास 3 A's हो सकते हैं. You can have 1A, 2A. Okay, 2A should not be accepted. So I should do something like this. I should make one more state here. So I should make it something like this. Here Q2 is there. Then I can have the state which is Q6, and this is A. And if I get one more A, I can go something like this. तो यहाँ पर क्या होगा? So whenever you have 0 A's, it is accepted. Whenever you have 3 A's, they are accepted. Then you can have A's which are multiple of 3's like this. तो इस तरह से आप हो सकता है. Now here in the beginning, if you do not get a A and if you directly get a B, then you can go to this state. So basically in this state I have given transition for both A and B. Now here also I have to give transitions for both A and B. So if you get a B here, then it should not be accepted. If you get a B here, it should not be accepted. Right, so we are going to get a state Q7, which is a trap state, and here if you get an A, it should not be accepted. Here if you get an A, it should not be accepted, and here also if you get an A, it should not be accepted. So for every state I've created transitions for A and B. So अगर आप यहाँ पर थोड़ा सा ध्यान से देखेंगे, if you look at it more clearly, तो अगर आपके पास 3 A's हैं, 1A, 2A and 3A. So whenever you get a 3 A's, it is accepting. Now if you get A's which are multiple of 3's, again it is accepting. But अगर आपके पास 3 multiple A जो है 3 के multiple B नहीं है, if you are getting a B in the between, so there is going to the state Q7, which is a rejecting state. So this should be a diagram for this problem. तो इस problem के लिए आपके पास ये diagram होना चाहिए. Okay, I hope that you understood this problem. So we have taken many problems till now. अब तक हम बहुत सारी problems ले चुके हैं, and we have mostly of these problems we have already solved. So आपके पास ये जो problems हैं, for example, these kind of problems we have already solved. These kinds of problems also we have already solved. So what I'm trying to do is take these 2 problems as a homework. Maybe you can try and solve these problems, and then I can tell you the solutions of this problem. How can you make DFAs for them? This problem we have already done. Okay. Now this is a problem that we can do now, which is if we get a string, and if that string is interpreted as a decimal number, and then it should be divisible by which of the following, right? So let us do this problem. Okay, guys, just say hi in the chat window to mark your presence. If you guys are not available for the session, then I will close the session. अगर आप available हैं, if you are still watching the video, please say hi. Otherwise I will close the session. Okay, so I was expecting a reply from a long time, but I think अब जाके मुझे reply मिल रहा है. So okay, good. So these problems till now we have seen. और इसमें कोई doubt है तो पूछ लीजिए. जय, प्रतिभा, if you have doubt please ask in this problem. अगर इसमें कोई doubt है तो मुझसे पूछ लीजिए. This is easy, right? But the thing is, it is just little bit complicated. So just lengthy, not difficult, not complicated, just lengthy. Okay, this is easy but little bit lengthy, that's it. Okay, hi Kavita, Harsh, Srinivas. Okay, so we have done problems till now. I hope आपको थोड़ा सा एक आइडिया लगा होगा what is a DFA and how can you make a diagram for DFA. Till now you must have got some idea about it. तो कुछ आइडिया आपको लगा होगा. So this is the problem, this is the last example problem for DFAs. तो ये जो प्रॉब्लम है ये आपका लास्ट एग्जांपल प्रॉब्लम है. सो व्हाट दे आर ट्राइंग टू से इज इफ यू गेट समेशन इज इक्वल टू 0,1 and then we can get a string. So we can have a string like 1 1 0 1 1, right? We can have a string like 1 1 0, we can have a string like 0 0 0, we can have a string like 1 1 1 and so on. So basically we can have any string, so that will be a binary string. So in this problem what we are trying to achieve is that if we divide the string by 2, अगर हम उस string को 2 से divide करेंगे, 2 in the sense उसकी decimal value को अगर हम 2 से divide करेंगे, then that should be accepted, otherwise it should be rejected. And here what we are trying to say is, if we take a binary string here like this, and if we divide the decimal equivalent value of that binary string, then if that value is divisible by 3, then it should be accepted. यानी कि जो भी string है अगर उसकी decimal value 3 से divisible है तो हम उसको accept करेंगे, otherwise उसको accept नहीं करेंगे. This is what we are trying to achieve. ठीक है? Is it clear what is the problem? So let us take the first part here. So first part is divisible by 2. Okay, the first part is divisible by 2. Now there are two cases here, and these are the two cases where students gets confused generally. Actually this thing is given different in different books. Some books says that if we have a string which is of length 0, 5, then we should say that it is divisible by 2. Okay, some says a string of length 0 is not divisible by 2. Okay, तो अगर आप कुछ बुक्स लेंगे, फॉर एग्जाम्पल इफ यू लुक एट अ बुक पीटर लिंस, तो पीटर लिंस में यू आर गोइंग टू गेट अ डिफरेंट आंसर. If you look at KLP Mishra, you will get a different answer. If you use a different book, again you will get a different answer. तो यहाँ पर हर एक बुक के साथ आपके पास अलग अलग आंसर्स गिवन है. तो अगर आप यहाँ पर चेक करेंगे, जैसे कि आपका केस 1 है, सो केस 1 में व्हाट वी आर अज्यूमिंग इज, लेट अस अज्यूम दैट एप्सिलॉन इज आल्सो डिविजिबल बाय 2. तो यहाँ पर क्या होगा, इफ यू गेट अ 0, 0 is divisible by 2. If you get 0, divisible by 2. We can get any number of zeros, they all are divisible by 2. But if we get a 1 here, it should not be divisible by 2, because जितने भी even number हैं, they always end with a single 0, so it is divisible by 2. We can have any number of ones, any combination of 1 here, but again if that combination is ending with 0, if the last, that means the rightmost bit here is 0, then it is divisible by 2. If the rightmost bit is 1, we can have any combination whatsoever, right? If the rightmost bit is 1, then it is not divisible by 2. Only thing is this bit here, the last bit should be 0. अगर last bit आपकी 0 है, then it is divisible by 2. In the second case, we are going to assume that epsilon is not divisible by 2. Epsilon जो है वो 2 से divisible नहीं है. So we are going to say that epsilon is not divisible by 2, and we are not going to consider that case. We are going to reject it. We are going to say any string which is ended with 0, that is divisible by 2. This is how we can do it. तो अगर आप इसको देखेंगे तो how can you do it? So this is the initial state Q0, and this is for the case number 1. So case number 1 में we are even trying to accept this, which is we are going to make initial state as a final state. Clear है? We have to make Q0 as final state, because this epsilon is also accepted. You can have any number of zeros in the beginning. आपके पास कितने भी zero हो सकते हैं, but as soon as get a 1, you go to the state Q1, you can get any number of ones. But if the string is ended by 0, अगर string 0 से end होती है, you will always end up at the state Q0. So this is a DFA, यानी कि if you take any of the strings, for example this is your string, and if you convert this binary value to a decimal value, so that decimal value should be divisible by 2. तो यहाँ पर this is 2, 4, 6, 2, 4, 8, and this is 16. So 16 plus 8 is 24, 24 plus 2 is 26, तो आपके पास नंबर आएगा 26, and that is divisible by 2. Now if you give this number to this DFA, अगर आप इस DFA को नंबर दोगे, so you will find out that this number is accepting here. So this DFA is going to accept this number. Okay, clear? Now if you take the second case here, so in the second case I'm going to assume that your epsilon is not divisible by 2. epsilon जो है वो 2 से divisible नहीं है. So in that case, initially we are at the state Q0, so that means epsilon is not divisible. So in the beginning we can get a 0, or you can also get a 1. If you get a 0, you will go to the state Q1, and that should be an accepting state. अगर आपके पास एक 0 आता है तो आप Q1 state पर जाएंगे, और वो एक accepting state होना चाहिए, because single 0 is divisible by 2. You can get any number of zeros here. But if you get a 1 after this, so that should go to the state Q3. You can get a number of 1 here, but as soon as you get a 0, again you should go to the state Q1. ठीक है. But the problem is this is not minimized. Here also I have to take a transition for 1, so that will not be minimized. So I have to minimize this diagram. So I can again minimize this diagram. I can make a minimal one. इसका एक छोटा वर्जन भी बनाया जा सकता है. So how can you do it? Initial state is Q naught. We are just assuming जो epsilon है वो 2 से divisible नहीं है. So अगर even if you are getting n number of ones, that is also not divisible by 2. जैसे कि अगर आपके पास है 1 1 1 1, so this is not divisible by 2 because this value is going to be 15. तो ये अगर आपका सिर्फ ones हैं तो वो भी आपके 2 से divisible नहीं है. But if the string is ended by 0, you'll go to the state Q1 and you are going to accept it. End में कितने भी 0 हो सकते हैं, but if you get a 1 in the end, so you'll go to the state Q1 also. So this is a basic diagram between both of them. तो दोनों में difference है. So you can try and understand these two diagrams. तो यहाँ पर ये दो अलग अलग cases हैं and these are two different answers in different books. तो अगर आप same problem को लेंगे अलग अलग books में, you will get different answers. Is it clear? And you cannot say that this answer is wrong. You cannot say this answer is wrong. Actually both of these answers are correct. जो दोनों जो answers हैं आपके, ये दोनों answers आपके correct हैं. None of these answers is wrong. Both of these answers are correct. Okay. Now this was the case when we were taking divisible by 2. Now we can take a next case when they are divisible by 3. Sorry. So question is divisible by 3. Divisible by 3. Okay. Again there are two cases. So we have first case number 1, when epsilon is also divisible by 3, and we have the second case is case 2, when epsilon is not divisible by 3. Okay. So basically I faced this problem when I started teaching. And when I was teaching this subject for the very first time, जब मैं subject को सबसे पहले first time पढ़ा रहा था, that time I faced this issue. So I created a diagram. Some student came to me, sir, the diagram you created is wrong. Then they showed me a proof कि सर ये book में है हमारे पास और इस book में ये diagram दिया हुआ है और आपने जो diagram बनाया है DFA का वो wrong है. So they showed me a proof. Then again I also showed them a proof. तो मैंने भी उनको proof दिखाया, उन्होंने भी मुझे proof दिखाया. And then again we came to a conclusion that both of us are not wrong. Because some books, some authors assume that epsilon is divisible by even 3, 4, 5 any numbers, right? And some authors say that it is not divisible. तो ये none of them is wrong. So आप नहीं कह सकते कौन सा गलत है कौन सा सही है. So you can easily figure it out. Okay. So let us take the first case here. तो पहला केस अगर हम लेते हैं, so let us try and figure out the properties of a number जो कि 3 से divisible होंगी. ऐसी क्या क्या properties हैं जो 3 से divisible हैं. जैसे कि here you can see epsilon should be divisible by 3. अगर आपके पास एक single 0 है, that is also divisible by 3. अगर आपके पास single 1 है, that is not divisible by 3. If you get a 1 0, that is if you get a 0 0, that is divisible by 3. If you get 0 1, that is not divisible by 3. If you get 1 0, that is not divisible by 3. If you get 1 1, that is divisible by 3. अगर आपके पास 0 0 0 है वो 3 से divisible है, 0 0 1 3 से divisible नहीं है, 0 1 0 3 से divisible नहीं है, 0 1 1 3 से divisible है, 1 0 0 3 से divisible नहीं है, 1 0 1 3 से divisible नहीं है, 1 1 0 is divisible by 3. In the same way, 4 times 0 is not divisible by 3, 0 0 0 1 not divisible by 3, 0 0 1 0 not divisible by 3, 0 0 0 0 1 1 is divisible by 3, 0 1 0 0 not divisible by 3, 0 1 0 1 not divisible by 3, 0 1 1 0 divisible by 3. And if you get 0 1 1 1 not divisible by 3, 1 0 0 0 not divisible by 3, 1 0 0 1 is divisible by 3, and so on. So basically here again you have to identify कि कौन सी ऐसी जो नंबर है बाइनरी नंबर जिसको अगर डेसिमल में आप कन्वर्ट करेंगे दैट इज डिविजिबल बाय 3। इसमें से आपको आइडेंटिफाई करना है कि ऐसी क्या प्रॉपर्टीज हो सकती है नंबर की दैट वी कैन से द नंबर इज डिविजिबल बाय 3। कैन यू आइडेंटिफाई प्रॉपर्टी हियर? थिंक अबाउट इट, राइट योर आंसर। क्या आप इसमें से कोई प्रॉपर्टी आइडेंटिफाई कर सकते हैं कि कौन सी नंबर 3 से डिविजिबल है? Can you identify any property here? So most of you cannot identify, right? It is not easy sometimes to identify properties. It is not easy sometimes to identify patterns. जैसे कि यहाँ पर कोई पैटर्न एग्जिस्ट तो कर रहा है, हम सबको पता है पैटर्न एग्जिस्ट कर रहा है. You know there is a pattern, I know there is a pattern. बट फिगरिंग आउट पैटर्न समटाइम्स बिकम्स डिफिकल्ट. कभी कभी ऐसा होता है कि पैटर्न्स को फिगर आउट करना थोड़ा सा डिफिकल्ट हो जाता है. सो व्हाट आर गोइंग टू इन दैट केस, उस केस में आप क्या करेंगे? आई एम गोइंग टू सी कि हम लोग ले रहे हैं दैट इज डिविजिबल बाय 3. हम लोग यहाँ पर सोच रहे हैं कि जो भी नंबर है वो 3 से डिविजिबल होनी चाहिए. तो यानी कि अगर कोई भी नंबर 3 से डिविजिबल होगी, सो यू आर गोइंग टू गेट 3 रिमाइंडर्स. आइदर यू आर गोइंग टू गेट अ रिमाइंडर 0 और यू आर गोइंग टू गेट अ रिमाइंडर 1 और यू आर गोइंग टू गेट अ रिमाइंडर 2. सो अगर कोई भी नंबर 3 से डिविजिबल होगी तो आपके पास सिर्फ 3 रिमाइंडर्स ही होंगे. सो व्हाट आई एम ट्राइंग टू डू हियर इज आई विल क्रिएट 3 स्टेट्स. आई विल क्रिएट अ स्टेट Q0, I will create a state Q1, I will create a state Q2, and I'm going to assume that this state is representing remainder 0, this state is representing remainder 1, and this state is representing remainder 2. Okay, इतना समझ आया कि मैंने क्या किया? सी I thought maybe there should be some pattern, but sometimes it can happen कि आप पैटर्न को आइडेंटिफाई ही नहीं कर पाओगे because questions and problems will become complicated and difficult. तो अब यहाँ पर आप क्या करेंगे? हमने एक बेसिक स्ट्रक्चर बनाया कि हमने बिकॉज हमें 3 से डिविजिबिलिटी का टेस्ट लेना है. सो एनी नंबर इफ इट इज डिविजिबल बाय 3 इट शुड हैव 0, 1 and 2 as remainders. So I'm going to take 3 states which is 0, remainder 1 and remainder 2. After this, because I said in the first case even epsilon is divisible by 3, right? So that means initial state should also be a final state. Epsilon को अगर आपको accept करना है, so I'm going to make this initial state Q0 and I'm going to make it as a final state. Why? Because epsilon is accepted here. This is the first case. अब second case, एक property यहाँ पर है, अगर कोई नंबर सिर्फ 0 है, या तो 0 है, 00 है, 000 है, 4 times 0 है. If a number is only 0, that is always divisible by 3. So that means I'm going to give a self loop here which is for 0. If you have 1 0, 2 0, 3 0, 4 0, it is always divisible by 3. Clear? If you get a number 1, here I'm going to produce a remainder 1. So अगर आपके पास 1 आता है, so we'll go to the state Q1. If you get a number which is 1 0, here in this case you will get a remainder as 2. So after this one, if you get a 0, you will go to the state Q2 because तब आपके पास रिमाइंडर आएगा. क्या आएगा रिमाइंडर? तब आपके पास 2. See, you only reach Q2 if you get 1 0. चाहे आपके पास कुछ ऐसा हो 0 0 0 0 1 0, तो उसकी जो डेसिमल वैल्यू है that should be 2, right? जैसे कि अगर आप देख सकते हैं यहाँ पर we can even have 0 0 0 1 0. तो यहाँ पर क्या है? 0 0 1 0, तो 0 0 1 0. तो आपके पास जो रिमाइंडर है वो तब भी आपके पास 2 आ रहा है. So you can see for the state Q0 I have given a transition for 0, I have also given a transition for 1. अब Q1 के अंदर I have given a transition for 0, but I have not given a transition for 1. मैंने यहाँ पर 1 के लिए कोई भी ट्रांजिशन नहीं दिया, लेकिन मैंने यहाँ पर 0 के लिए ट्रांजिशन दिया है. तो अगर मेरे पास कभी ऐसा हो कि इस 1 के बाद दोबारा से 1 आ जाए, जैसे कि I told you if we get 1 1, ये आपके पास एक केस है 1 1, और you get 0 1 1, और you get 0 0 1 1, तो that is divisible. That means after this one, if you get one more 1, तो now this number is divisible. Okay. अब जो आपका Q2 है, now for Q2 we have to give transitions. Q2 के लिए अब हमें ट्रांजिशन देना है. अब आपके पास अगर 1 0 है, उसके बाद अगर एक और 0 आता है, जैसे आपके पास एक नंबर है 1 0 0, so this number is giving a decimal value of 4. अगर आप इसको डिवाइड करोगे 3 से, सो रिमाइंडर शुड बी 1, राइट? सो 1 0 और उसके बाद एक और 0 आ जाए, so you should get a remainder 1. ठीक है, but if you get 101, तो 101 के केस में क्या है, the decimal value is going to be 5. So if you divide this decimal value by 3, so remainder will be 2, so that means 1 0, and if you get 1, so remainder to be 2. अब आप देख सकते हैं, I do not know whether it is correct or not, so what I try to do is I just try to figure out कि किस केस में क्या हो रहा है, और उसके अकॉर्डिंग I just created some transitions. I'm not sure whether it is correct or not. I can just try and correct it. I can just try some random numbers also, जैसे कि देखते हैं. Let us see if it is correct or not. देखो, just look at it carefully now. If I have a number which is 110110, I've taken this number very randomly. I don't know इसकी वैल्यू क्या है. I can take one or two more numbers randomly. 1111 base 2. I can have 10110. 2. I can have 0010111010 something. Some random numbers I have taken. I don't know what are their values. तो अगर आप पहली नंबर चेक करेंगे, this value is going to be 2 raised power 0. This is 2 raised power 1. Sorry, this is 2 raised power 1. This is 2 raised power 2. 2 raised power 3. This is 2 raised power 4, and this is 2 raised power 5. So it is 32 plus 16. 32 plus 16 is 48. 48 plus 4 is 52. 52 plus 2 is 54. This number is actually representing 54. And if you divide 54 by 3, you will get a remainder as 0. यानी कि अगर हमें इस नंबर को इस डायग्राम में देंगे, we should get as 0. ठीक है, चेक करते हैं. पहला 1 आया, सो Q0 से Q1 के पास गए. 1 आया, Q1 से Q0 के पास गए. 0 आया, Q0 से Q0 के पास रहे. 1 आया तो Q0 से Q1 के पास गए. 1 आया, Q1 से Q0 के पास गए. 0 आया और Q0 से Q0 के पास ही रहे. So after reading this entire string, we are at the state Q0, and we know that 54 is divisible by 3, hence this one is correct. The first part is correct. Okay, clear? Sure, I'll just speak in English. So second case here is, we know this value, and this value is actually 15, and we know that this number is divisible by 3. But let us check if this number is divisible by 3 in this case also. 1 from Q0 will go to the state Q1. Again 1 from Q1 will go to the state Q0. Again 1 from Q0 will go to the state Q1. Again 1 from Q1 will go to the state Q0. So again you can clearly see this is also accepted in this diagram. Okay, so both of these two numbers are divisible by 3, hence both of them are being accepted. So if you take the third case here, so what is this value? This is 2 raised power 0, this is 2 raised power this is 2 raised power 1, 2 raised power 2, 2 raised power 3, and this is 2 raised power 4. That is 16 plus 2, 18, 18 plus 1 is 19. So 18 sorry, this is 16 plus 4 plus 2, which is 22. Now this number is 22, and if you divide 22 by 3, you should get a remainder as 1. You should get a remainder as 1. So that means if I give this number to this diagram, we should be at the state Q1. So let us check. 1 from Q0 I'll go to Q1. 0 from Q1 I'll go to Q2. Again 1 from Q2 I'll go to Q2. Again 1 from Q2 I'll go to Q2. Again 0 from Q2 I'll go to Q1. So you can see here we get a remainder 1, and we are remaining at the state Q1. तो यहाँ पर हम इसको देंगे तो हम लोग Q1 के पास ही रहेंगे. We'll stay at the state Q1 after giving this string. I hope that you understood this one. Now let us take the last one. So last value is this is 2 raised power 0. Sorry, this is 2 raised power 1. This is 2 raised power 2. This is 2 raised power 3, and this is 2 raised power 5. So that means it is how much? 32 plus 8 plus 4 plus 2, which is how much? 40. 40 plus 6 is 46. So if you divide 46 by 3, I think you should get a remainder as 1. So let us take one more value. If I change this value also as 1, so I think this number should become 47. Okay, so 2 raised power 0, 2 raised power 1, 2 raised power 2, 2 raised power 3, and 2 raised power 5. So this entire sum should be 47. And if you divide 47 by 3, so we should get a remainder as 2. अगर आप 47 को 3 से डिवाइड करेंगे, if you divide the number 47 by 3, you should get a remainder by 2. So that means if I give this number on this diagram, we should be at the state Q2. तो उस केस में we should remain at the state Q2. So let us try and give this. So first number is 0. So from Q0 we'll go to Q0. Next is 0. From Q0 we'll go to Q0. Next is 1. From Q0 we'll go to Q1. Next is 0. From Q1 we'll go to Q2. Next is 1. From Q2 we'll go to Q2. Next is 1. Q2 to Q2. Again 1. Q2 to Q2. Again 1. Q2 to Q2. So after giving this entire number, we are staying at the state Q2 because we are getting the remainder as 2. I hope that you understood this part. So this was the first case when we assume that even epsilon is divisible. The first case में हमने assume किया, we just assume that even epsilon is divisible. But if you take the second case here we are assuming that epsilon is not divisible. So for the second case you have to create a different diagram. Any doubts here till now? Any doubts so far? Pratibha, Kavita, Srinivas, Somya, Kamilini, Kavita, Jay, Harsh, all those who are present? Good. So that means you guys are super smart, super intelligent and superhuman. I don't know, I'm not such a good human, but you guys are super smart. So we have created two diagrams so far. We have created one diagram for divisible by 2 and we have created one diagram for divisible by 3. So let's try and figure out their tables also. So for divisible by 2, if I take divisible by 2, so in that case, I think you remember the diagram, we create something like this, Q0, initial and final state. If you get a 0 here, if you get a 1 here, we go to the state Q1. Again, if you get a 0, we'll go to the state Q0 and we can get 1s here, right? So this was a diagram for divisible by 2 and this was a diagram for divisible by 3. Okay, so these are two different diagrams. If you make the state transition table, state transition table for them. So if you create a state transition table for this, so you will understand that we got two remainders here and there are two inputs 0 and 1. So there's an input 0, there's an input 1 and the remainders are Q0 and Q1. So here the initial state is Q0 and here the final state is Q0. So I'm going to put a star here. I think some of you know how can you create a transition table. So how do you create a transition table? So in a state transition table, you are going to put all your inputs here and you are going to put all your states here. If a state is an initial state, I'm going to put an arrow. If a state is a final state, I'm going to put a star. Now in Q0, if you give a 0, you'll go to the state Q0 only. In Q0, if you give a 1, you go to the state Q1. In Q1, if you give a 0, you go to the state Q0. In Q1, if you give a 1, you go to the state Q1. Okay. Now in the same way, if you check the second diagram here, so for this diagram, how many inputs are there? There are only two inputs, which is 0 and 1. And how many states are there? There are 3 states which is representing, every state is representing one remainder. So we have states which is Q0, Q1 and Q2. Okay. Now in Q0, if you give a 0, you go to the state Q0. In Q0, if you give a 1, you go to the state Q1. In Q1, if you give a 0, you go to the state Q2. In Q1, if you give a 1, you go to the state Q0 again. So if you put this one for Q2, this is Q0 and this is Q1 and Q2. Okay. So this is a state transition diagram for this problem. This is a state transition diagram for this problem. Okay. Now, before solving the second case, before I solve the second case, let me give a shortcut. Let me give a shortcut here. I have a very good shortcut here. Let me create a diagram for 4 and 5. तो 4 और 5 के लिए state transition diagram बना सकता हूँ, but before that I can just make a state transition table. There exists a shortcut here. What is the shortcut? Shortcut is like this. For this specific problem, this is just for this problem and only in the case when you are going to assume that even epsilon is divisible by the number. Again मैं repeat कर रहा हूँ, so I'm just repeating it again. जो शॉर्टकट है ये सिर्फ इस केस में वैलिड है जहां पर आपको नंबर लेना है, जैसे कोई नंबर 4 है, 5 है, कोई भी नंबर है, द शॉर्टकट इज ओनली वैलिड ओनली एंड ओनली इफ यू आर गोइंग टू assume that epsilon is also divisible by that number, and it does not guarantee that you always get a minimal diagram. Sometimes it can happen that you might not get a minimal diagram, but you'll understand, right? So it is a shortcut, right? So if you want to have a divisibility test, so divisible by 4, for example, divisible by 4. So easiest way is, in the state transition table, just write the input values. So input is 0 and 1, and here because it is divisible by 4, so we are going to get 4 remainders, which is Q0, Q1, Q2 and Q3. So there can be 4 remainders, which is remainder 0, remainder 1, 0, remainder 2 and remainder number 3. There can be 4 remainders. For every remainder I'm going to create a state which is Q0, Q1, Q2 and Q3. And because we wanted that epsilon should also be accepted, so this is the initial state as well as it is also a final state. Now what I have to do is I have to fill them in order: Q0 and Q1, Q0 and Q1, Q0, Q1 and Q2, again Q0, Q1 and Q2. So this same order I'm going to follow. So again I'm going to do Q0, Q1, Q2, Q3, Q0, Q1, Q2 and Q3. This is done. This is the transition table for divisibility by 4. Very easy. You can just look at this transition table and you can make a diagram like this. In the same way, if I want to make a table for divisible by 5, there exists a shortcut again, similar kind of shortcut here also. So what you are going to do is, what are the input values? The inputs are 0 and 1, and because we are doing divisible by 5, there can be 5 remainders. The remainders can be 0, 1, 2, 3 and 4. That's it. All you have to do is fill this table in the same order. So it is Q0, Q1, Q2, Q3, Q4, Q0, Q1, Q2, Q3 and Q4. That's it. The problem is solved. Now using this diagram, using this table, you can create a diagram like this, and that diagram will be the divisibility test by 5. So the diagram hoga, that will give a divisibility test by 5. Clear? It's a very easy shortcut, right? One of the easiest thing that you can ever come across, the easiest shortcut or short trick to solve this problem. है ना? Good. Now this trick is also valid if you have numbers which are of different bases. अगर आपके पास numbers हैं which are of different bases, in those cases also this thing is valid. This thing is valid. This thing is valid. How? कैसे? आखिर क्यों? How can this be valid, sir? How can you say that? How can you do it with us? Let me show you, sir. So if you have problem like, if you have summation is equal to 0, 1 and 2, or if you have summation is equal to 0, 1, 2 and 3, if you have summation is equal to 0, 1, 2, 3 and 4, or anything whatsoever, you can have any symbols here, correct? So for example, this summation is containing only 2 symbols, which is 0 and 1. So every string will be a binary string. This summation is containing 3 symbols, which is 0, 1 and 2. So every string will be a ternary string. Ternary means they are going to have 3 symbols. So this is having 4 symbols, which is 0, 1 and 2. So every string will be a quinary string. So let me just show you with the help of an example. What I mean to say is, if I take this one, if I take any random string, for example the string is 0, 1, 2, so here the base will be 3. So if you convert this number to a decimal number, so you have to do 2 into 3 raised to power 0 plus 1 into 3 raised to power 1, which is 3 plus 2 is 5. So equivalent decimal number is 5. If I take this one, and if I take any number like 0, 1, 2, 1, and this is, in this case, because we are having 4 symbols, so it is base 4. So if we convert this number to a decimal number, so it is 0 into 4 is power 0 plus 2 into 4 is power 1 plus 1 into 4 is power 2. So this is 16 plus 4 is 20, 20 plus 1 is 21. So in decimal this value is going to be 21. Okay. So you can have numbers which are of different bases, right? So here the base is going to be 4 because there are 4 symbols. Here the base is going to be 5 because there are 5 symbols, and here the base is going to be 3 because there are 3 symbols. So you can also have a number which is summation is equal to 0, 1, 2 up to so on n. So here the base is going to be n. And let us suppose we want to have divisible by x. Divisible by x. So if you check the first case, अगर आपको first case in the first case, so what we have to do is, because the number is x can be anything, so there can be x remainders also. The remainders can be 0, the remainders can be 1, the remainders can be 2, the remainders can be x minus 1. So total x remainders are possible, correct? Now for example, if I say divisible by 4, right? So that means there are 4 remainders are possible, which is 0, 1, 2 and 3. Divisible by 4, that means 4 remainders are possible. So that means if you take the first problem here, if you want to create a straight transition diagram, that is your DFA for this, all you have to do is, because there are 3 symbols, so you have to write 0, 1 and 2, and because you want to divisible by 4, divisible by 4 means there are 4 remainders, so it is Q0, Q1, Q2 and Q3. All you have to do is fill this table. So all you have to do is Q0, Q1, Q2, Q3, Q0, Q1, Q2, Q3, again Q0, Q1, Q2 and Q3. That's it. The problem is done, solved, right? So it is so easy. Just by looking at it, you can easily create a DFA that will divide a ternary number by 4, and whatever remainder you want, if you want a remainder 1, then you are going to make this as a final state. अगर आपको remainder 1 चाहिए तो आप Q1 को final बनाओ. If you want remainder as 3, so make Q3 as final. If you want remainder as 0, then make Q0 as final. So in general, what you are going to do is, whenever we have a divisibility test by any number, right? So what you have to do is write all the numbers here, like 0, 1, 2, 3 up to so on n, all the input symbols. And then if I say divisible by x, so that means I'm going to have a state which is Q0, Q1, Q2 up to so on Q of x minus 1, Q of x minus 1, and just fill this table like Q0, Q1, Q2 up to so on Qx minus 1, again Q0, Q1 up to so on Qx minus 1, again up to so on. So you can just fill this table in this manner and you will get the divisibility test and the DFA is done. So all you have to do is, whatever the number of inputs you have, so if you have 3 inputs, write 3 inputs here. If you have 4 inputs, write 4 inputs here. If you have 5 inputs, write 5 inputs here. If you have test by x, so write x states here, which is 0 to x minus 1, and just fill this in the same order and your problem is done. That is the shortcut, correct? And this shortcut is only valid if and only if you are going to imagine that even epsilon is divisible by that number, right? Doubts, my dear friends? Do you have any doubts? Good. So now there is a second case also. The second case is when you are going to imagine that epsilon is not divisible. If you say that epsilon is not divisible, then you have to write a solution for that also. Okay, epsilon अगर divisible नहीं है, then you have to figure it out. How can you solve this problem? Okay, take that as homework. If we assume that epsilon is not divisible, then how many states can be there? So let me give a homework. So the problem is, if I say I want to have a divisible by 3, but epsilon is not divisible. Epsilon is not divisible, correct? And so you can figure out what is the number of states, how many states you want, and the input is 0, 1. So you just have a binary string. For this binary string, you have to create a DFA where it is going to accept the strings which are divisible by 3. And here epsilon, we are going to imagine epsilon is not divisible by 3. Okay, so you can solve this problem, I guess. Clear? You can do it. Can we move ahead? Good. Yeah. Good. So let's move ahead. Let us look at what is NFAs. तो अब तक हमने देखा, we have seen what are DFAs. Now we'll be seeing what are NFAs. So this is the second part here. Let me just see if you can, yes, if you're right. So this is the problem. What are NFAs? Just change the marker. So can you give me marker ink? चले जाओ वहाँ से, कोई प्रॉब्लम नहीं है, चले जाओ आगे से, चले जाओ. Just give me a second, let me just fill my markers. Hi Anuradha. So next one is NFA, which is non-deterministic finite automata. So till now we have seen what is a DFA. Now we will be looking at what is an NFA. Okay. So as I said, if you look at a DFA, then the definition of a DFA is Q summation delta Q naught and F. And if you look at an NFA, then definition here is Q summation delta Q naught and F. So both are the same number of tuples. Okay. Then sir, what is the difference, sir? Sir, what is the difference, sir? What is the difference between both of them, sir? See, in both of them, Q is same. So Q is non-empty set of states. Summation is again non-empty set of input alphabets. Delta is a transition function, so there is a difference in delta in both of them. So if you take this delta for DFA, so delta is Q cross summation takes us to 2 raised to power Q states. In case of NFA, delta is Q, sorry, so here it is Q states and here it is Q cross summation takes us to 2 raised to power Q states. Sorry. Now in this case, what it means is that for every symbol we have to give a transition and there will be exact transition, and here we can have more than one transition. What do I mean to say by this is, let us say let Q is equal to Q0 and Q1. So Q अगर Q0 and Q1 है, that means we are going to have two states here, correct? And let us say let L summation is equal to A comma B. So that means if I say delta Q cross summation, it means Q0 comma Q1 cross A comma B, right? So this is a cross product of two sets. So this cross product will result as Q0 comma A comma Q0 comma B comma Q1 comma A comma Q1 comma B. Okay, so this will be the cross product. Cross product means here again you can see everything here is mapped with exactly one. Yes, I think it was buffering, now it is fine. Good. So Anuradha, please change the video resolution. I think you'll get it then. Fine. So if you do this first part, which is Q cross summation, so it is going to be Q0 comma Q1 cross A comma B. So basically this is your set Q and this is your set summation. So basically it is a cross product of two sets. So cross product of two sets gives you every possible combination. Now the only important part here is this second part. So because this first part is common in both of them, ये जो first part है ये common है दोनों के अंदर, this second part is common, and because of this arrow we are just trying to represent the mapping. इस arrow से हम लोग सिर्फ mapping को represent कर रहे हैं. Okay. So here in this case of DFA, this set is Q again, but in case of NFA this set is 2 raised to power Q. That means it is representing a power set of Q. It is representing the power set of Q. That means if Q is Q0 comma Q1, then power set of Q is going to be an empty set which is phi comma a set which is only containing Q0, a set which is only containing Q1, and a set which is containing Q0 and Q1. Okay. So what do I mean to say by this is, in case of DFA, these things are going to be mapped with exactly one state. That means if I say, अगर हम लोग किसी एक state पर, if you are at a state Q0, if I see a symbol A, then I will go to one unique state. मैं सिर्फ एक ही state पर जाऊँगा. If I am at a state Q0, if I see a symbol B, I will go to one unique state. I will not go to two different states. So यहाँ से I'm not going to two different states. But in case of NFA, this means that if this is a set of Q, which is Q0 and Q1, and this is a cross product between summation, which is A and B, then the mapping is to this set. And in this set we have phi, we have Q0, we have Q1, and we have Q1 comma Q2. Sorry. So that means on this set it can happen if we are at a state Q0, if you see a symbol A, you might go to phi also, यानी कि आप किसी state पर नहीं जा रहे. So that means we can also have null transition and we can also have multiple transition. हम यहाँ पर null transition भी हो सकते हैं और we can also have multiple transitions. कुछ समझ आया? I don't think so that you understood anything. But you will only understand if I take an example. I don't think so by this definition you understood anything. This is just like a bookish definition. So bookish definition say nobody understands anything. So let me give an example first of all. Then maybe there's a chance that you will be able to understand. So let us say we have an example like this. So we take an example. So example is strings that are starting with A, okay, where summation is equal to A comma B. strings that are starting with A. So Mishra is equal to Ekmavi. So Pratibha, please make sure, and Jay, please make sure that you do not miss this part, because this part is very, very important for you. Because you guys are studying the subject for the very first time, so this example will clear what is the difference between both of them. Okay. So if in this case we have already solved this problem, we know if I create a DFA for this, then the DFA will look something like this, which is Q0, which is initial state. In the beginning, if you get a A, you go to the state Q1, and this is going to be a final state. After this, you can have any combinations of A and B. And in the beginning, if you get a B, you go to the state Q2, and here it is going to be a trap state. This is something that we have seen. ये हम already देख चुके हैं. But let me tell you something interesting here. This thing, this entire thing, which is solving this problem, it is a DFA as well as it is also a NFA. ये एक DFA भी है and as well as it is also a NFA. So basically every DFA is NFA. जितने भी DFA हैं वो सभी NFA भी है. You will understand what I'm trying to say. But if I solve the same problem using this, we are at a state Q0. If we see a symbol A, I'll go to the state Q1. After this, I can have any number of A and B, and this is a final state. Now this diagram here, this entire diagram, this is an NFA, but it is not a DFA. It is not a DFA. So this is saying if the initial symbol is A, after this I can have any combination of A and B and I'm going to accept it, but we are not telling if we have B. If the initial symbol is B, we are not telling anything. Only we are saying is if the initial symbol is A, then we are just accepting everything, right? So basically what it means is if you are at a state Q0, if you see a symbol A, right, then you are going to the state Q1. But if you are at a state Q0, if you see a symbol B, then you are going to 5. तो उस केस में आप 5 पर जा रहे हैं. So उस केस में you are going to 5. Clear? So that means it can happen if you are at a certain state. By seeing a symbol, you are not going anywhere. You are not giving a transition. If you look at this diagram, if you are at state Q0, if you are looking at a symbol B, you are not going anywhere. You have not given any transition for B. आपने B के लिए कोई भी transition यहाँ पर नहीं दिया है. But here you have given a transition for B. So in every DFA, for every state, you will be having exactly one transition for both A as well as for both B. Here also you should have a transition for A and B. Here also you should have a transition for A and B. But here in this case, in case of NFA, it might happen you might miss some transitions. And secondly, it might also happen that by looking at a same symbol, you can go to more than one states. आप एक symbol को देखकर एक से ज़्यादा states पर भी जा सकते हैं. So in NFA, two things are possible which are additional. So you might go to a 5 state, which is an empty state. That means you are not going anywhere. Or you can go to more than one states by looking at a same symbol. But in case of DFA, the transition is you should give transition for every symbol. There is no options for 5 and there is no options for multiple states. Is it clear? Still, if it is not clear, I'll take one more example. Please write it down. Write this down in your notebook, and after writing it down, just write done in the chat window. I'll take one more example. Tab tak please write it down in your notebook and write done. Jay. Is there anyone else here? Okay, Let me give one more example. Let me take one more example here. Then maybe you will understand, my dear friends. So I feel that you have not understood any single word whatever I have said. मैंने जो भी बोला आपको कुछ भी समझ में नहीं आया. So I'll take one more example. Okay? थोड़ा प्यार से करेंगे, अच्छे से करेंगे. So keep it raw. So let us assume that the example is like this: strings starting with AB, and where summation is equal to A comma B. String starting with AB. This is the language. Now for this language I can create a DFA, but as I said, every DFA is also an NFA. But there are some NFAs which are not DFA. Okay, I'm not discussing about their power because both DFA and NFA are equivalent in power. I'm just saying every DFA is NFA, but every NFA is not DFA. Okay, so if I create a DFA for this, then DFA will look something like this, and I'm creating a minimal DFA, that means which is having minimum number of states. Initially you are at state Q0. Okay, now if I see a symbol A, I'll go to the state Q1. But if I see a symbol B in the beginning, I'll go to the state Q2, and this Q2 is going to be a dead state, or you can say trap state. Here if I see a symbol A again, I'll go to the state Q2, but if I see a symbol B, I go to the state Q3, which is an accepting state, and this is final. Now this is the diagram which is solving this problem. This diagram is both a DFA as well as this diagram is also an NFA. So every DFA is an NFA. But I can also create one more diagram which is solving the same problem. The diagram looks something like this, which is initial state, you are at state Q0. First, if you get a A, you go to the state Q1. Then if you get a B, you go to the state Q2. And then you can have any combinations of A and B. Now this is also a solution of the same problem. And this is a correct solution. इसमें कोई problem नहीं है. This is not a correct, this is not a wrong solution. This is a correct solution. Okay. Is it buffering? Let me have a look. Is it buffering, guys? No buffering. Okay, so it was buffering on my end, so that's why I asked. Sure, no problem. So let's continue then. Great. So if you look at these two diagrams, so what it means is this is the set of states. In this case we have three states, which is Q0, Q1 and Q2, and we have two input symbols, which is A and B, and here we have the power set of this. तो यहाँ पर power set अगर आप लेंगे, so how many elements will be there? There will be total of 8 elements in the power set. Okay, so I have to make this one as bigger, so this is slightly bigger. So in the power set you are going to have 5. You can have a single A, you can have a single B, you can have a, so this is actually not AB, this is Q1, this is Q2, this is Q3, you can get Q1 and Q2, you can get Q2 and Q3, you can get Q1 and Q3, and you can get Q1, Q2 and Q3. Music. So I think you might also be having this noise, I don't know, something is going on outside too. So here you can see this is representing the power set. This is the power set of Q, and this is the set Q. Okay, so if you look at it here, if you are at state Q0, by looking at the symbol A, you are going to the state Q1. If you are at a state Q0, by looking at a symbol B, you are going to 5. Clear hai? Is it clear that we are not making any transition for symbol B? If you are at a state Q1, by looking at a symbol A, you are going to 5. If you are at state Q1, by looking at a symbol B, you are going to the state Q2. Okay, so that means here I'm not giving any transition for B, and here I'm not giving any transitions for A. Okay, but here if you look at it here, so for every state we have exactly 2 outgoing transitions. हर एक state के लिए आपके पास exactly 2 outgoing transitions है. Okay, and when do we say a string is accepted here? When can we say a string is accepted? When can you say a string is accepted in this case? आप किस केस में कहेंगे कि जो string है वो accept हो रही है? How can you say it? When can you say it? A string is accepted. You can only say a string is accepted if by giving that string you are reaching to a final state. अगर आप string को देने के बाद आप किसी तरीके से if you reach to a final state, then we say that the string is accepted. तो अगर if you give that string, okay. Now for example, let me give an example. We are saying string starting with AB, okay, but if a string does not start with AB, that means the string is AAB, right? So this string should not accepted. Why? Because it is not starting with AB. This string is starting with double A. ये जो string है double A से start हो रही है, it is not starting with AB. So if you give this string to this diagram, what happens in that case? In Q0, by giving a first A, you are going to the state Q1. And in Q1, by giving one more A, you are going to phi. So that means this is going to a dead configuration. This is going to a dead configuration. So if you reach a dead configuration, that means the string is not accepted. Sometimes it can happen by looking at a symbol, you are going to more than one states, and if any one of those states is a final state, then the string is accepted. But here you can see by giving this string you are going to a dead configuration, that means the string is not accepted. If you give a string like BAA, right, so first symbol is B, so if you are at state Q0, by giving the symbol B you are going to phi, which is a dead configuration, that means BAA will not be accepted. So ये जो string है ये accept नहीं होगी. Is it clear? What's the difference both of them? Let me give you one more example for the difference. If it is clear, I'll give you one more example. एक और example मैं आपको दूंगा, so that you will be able to figure out the exact difference between both of them. What is the difference between an NFA and a DFA? If I say that summation is equal to A comma B and language is strings ending with AB, strings are ending with AB. So I can make a diagram very straightforward. The diagram is something like this. This is the initial state, which is Q0. In beginning you can have any combination of A and B, but as soon as you get a A, you go to the state Q1. Again if you get a B, you go to the state Q2, and Q2 is a final state, and done. This is your NFA. This is your NFA. It is not a DFA. DFA में जो word आता है D, D का मतलब क्या है? D means determinism. D means deterministic, which means determinism. So determinism मतलब, what do you mean by determinism? Determinism is something that you can say about something in full confidence. If you are discussing about something, if you are saying about something, and if you tell about this thing of full confidence that this will do exact this word, it will not do anything else, then that is called as determinism. Sometimes you are not deterministic, right? So you are doing something which is exceptional, which is not, you cannot really say that this is exact thing that you are going to do. Nobody can even predict what you are going to do. That is called as non-deterministic. तो यहाँ पर क्या आपके पास, here in this case, this is a non-deterministic. Why it is a non-deterministic? So we are trying to create a NFA for the strings ending with AB. That means if you have a string like AABAB, now this string should be accepted because here this string is ending with AB, so this string should be accepted. So what will happen if you give this string to this diagram? So initially you are at state Q0. After giving a you are making two transitions. So अगर आप A को देंगे, if you are giving a you are going to the state Q1, as well as if you are giving a you are also going to this loop which is Q0, right? So you are making two different transitions. So that means by looking at a symbol A, you can go to Q0 as well as you can also go to Q1. Okay. Now अगेन इफ यू आर गिविंग अ ए, सो इफ यू आर एट स्टेट क्यू नॉट, तो फिर से आपके पास दो चॉइसेस, टू चॉइसेस. सो अगेन यू कैन गो टू क्यू नॉट और you can go to Q1. But here if we are in Q1, if you are giving a symbol A, then you will go to phi. This is dead. Okay. Now second is B. Second symbol is third symbol is B. So if you are at state Q0 and if you are giving a symbol B, then you will go to Q0 only. But if you are at state Q1 and you are giving a symbol B, then you will go to Q2. And Q2 is a final state. Okay. Now the fourth symbol is A. So if you are at state Q0, if you have given A, then you might go to Q0 as well as you might also go to Q1. But if you are at state Q2 and if you are giving this symbol A, then you will go to phi. Okay, so this is basically I'm tracing out what happens if you have multiple choices. Then the last symbol is B. Now if you are at state Q0, by looking at a symbol B, you will go to the state Q0 only. But if you are at state Q1, by looking at this B, you will go to Q2. Now we read this entire string. After reading this entire string, whatever the last states will be, you can have 1 state, 2 states, 3 states, 4 states, 5 states, you can have any number of states. Whatever the last states will be, if at least one of those states is a final state, for example here Q2 is a final state, जितनी भी स्टेट होंगी लास्ट में, अगर उसमें से एक भी स्टेट आपकी फाइनल स्टेट है, सो Q2 इज अ फाइनल स्टेट. अगर लास्ट में कोई भी एक स्टेट फाइनल स्टेट है, दैट मीन्स द स्ट्रिंग विल बी एक्सेप्टेड, अदरवाइज द स्ट्रिंग विल नॉट बी एक्सेप्टेड. तो हियर कैन सी वी हैव क्रिएटेड मल्टीपल ब्रांचेस on state Q0 because we have multiple options for the same symbol. So for on the state Q0 we are creating multiple branches. So on Q0, whenever you are getting a A, you are creating a branch. Whenever you are getting a A, you are creating a branch. Whenever you are getting a B, you will go to the state Q0 again. So right, so but whenever you are getting a A, you are creating multiple branches. So that means you cannot determine on one exact state where you can go if you get a A on the state Q0. So this diagram is basically representing a non-deterministic finite automata. It is not representing a deterministic finite automata. If you want a deterministic finite automata for this diagram, so deterministic will look something different. So what is the DFA for this? What is the DFA for this? So DFA will be different. What will the DFA? DFA will be something like this. This is the initial state Q0. If you get a symbol B in the beginning, you go to the state Q1, which will be a dead state. But if you get a symbol A, you go to the state Q2, and here if you get a symbol B, you go to the state Q3, which is the accepting state. But if in Q2, if you get a A, you will go to a dead state. In Q3, you can get a A, or after this, you can get a B. You go to the state Q4, which is a totally accepting state, which should not be accepted actually. Sorry, I'm so sorry. This is I created a wrong diagram because I was thinking of something else. I don't know what I was thinking, but leave it. So this is a string ending with AB. So that means if you are at state Q0, in the beginning you can have any number of B's. If you get a single A, you go to the state Q1. On the state Q1, you can get any number of A's. If you get a B, you will go to the state Q2. I'm going to say that Q2 is an accepting state. Here if you get a A, you will again go to this. If you get a B, you will again go to this. So this is representing a DFA. This one is a DFA and this one is an NFA, and both of them are actually representing the same problem. So यहाँ पर what happens is on every state you have exactly 2 outgoing transitions. You have exactly 2 outgoing transitions. You are not having more than 2 outgoing transitions. And here you can have more than 2 outgoing transitions because here it is, these are for A and B, and this is for A. So there are 3 transitions here, and here we have only 1 transition. Here we do not have any outgoing transition, but in case of DFA we should have outgoing transitions which are exact 2. So यहाँ पर भी it will accept all those strings which are ending with AB. If a string is not ending with AB, it will not accept it. It will also accept only those strings which are ending with AB. If the string is not ending with AB, it will not accept it. So this is a huge difference between both of them. I think by this example it should be clear to you what is the difference between an NFA and DFA. So by definition we say every DFA is also an NFA, but every NFA is not a DFA. जितने भी NFAs हैं वो DFA नहीं है, हर एक NFA DFA नहीं हो सकता, but every DFA is an NFA. क्लियर? प्रतिभा, प्लीज आस्क योर डाउट. प्रतिभा, अगर आपको डाउट है तो प्लीज आस्क मी, बिकॉज दिस थिंग शुड बी क्लियर. अगर ये आपको क्लियर नहीं होगा, इफ दिस थिंग इज नॉट क्लियर, देन यू विल फेस प्रॉब्लम. दिस थिंग इज वेरी वेरी इंपॉर्टेंट कि आपको क्लियर हो. इट शुड बी क्लियर. Okay, so I believe you understood the difference between NFA and DFA. So maybe the huge number of problems where we can basically use these NFAs, because it is generally very very easy to create NFAs as compared to DFA. Generally बहुत easy होता है that we create NFAs as compared to DFAs, and then we can convert those NFAs to DFAs according to the problem. Sometimes in the examination this will help you a lot, that you can create NFA first and then you can convert a DFA, right? But make sure that you do not create it. See, the biggest problem with the students is when they try to understand an NFA, जब वो NFA को understand करने की कोशिश करते हैं, they try to create an NFA for a problem, they can still make an NFA wrong. This NFA will be wrong if I remove this transition. अगर मैं इस transition को remove करता हूँ तो ये NFA जो है वो गलत हो जाएगा. Why so? See, the basic property, the thing that you should focus, जो सबसे ज़्यादा आपको important है, NFA should always accept those strings which are present in the language. Okay? Sometimes people will create NFAs where the NFAs are not accepting those strings which are actually present in the language. If a string is present in the language, that should always be accepted by an NFA. If that NFA is not accepting that string, that means NFA is wrong. Now for example here, if you say the string which is AAB, now this string is present in the language, but this string will not be accepted by this NFA. Why? After giving the first A, you will go from Q0 to Q1. After giving the second A, from Q1 you are going to a dead state, or you can say you are going to dead configuration. So this string will not be accepted even though this string is present in the language. So that means this NFA is not correct. Okay, so whenever you create an NFA, it should always accept those strings which are actually present in the language. If it is not accepting those strings which are present in the language, that means it is wrong. Is it clear? Fine. So let's do this now. This was the first session, and this first session which was of approximately 2 hours. तो ये 2 घंटे का सेशन था हमारा. Now we will do the second session after some break. We will take a break of maybe 15 minutes or something. तो I'll update you in the Telegram group, and then we will start the second session. उसके बाद हम लोग अगला सेशन स्टार्ट करेंगे. Okay? So take a break, and this was approximately a 2-hour session. And after the break we will start our next session. अगर कोई डाउट है, if you have any doubt, please ask. Clearer and clean and clear. Thank you. Great.